In this video, we are going to look at how we can construct polynomials of any degree in Matlab. And later on, we are going to look at how we can integrate them. So let's begin by defining our symbolic variables. Now we are going to have maybe x, then t, maybe y. Okay, so after defining our symbolic variables, we can construct immediately our polynomials. So I can say our first polynomial of degree 2 has got 3 coefficients. If it is degree 3, it will have 4 coefficients. If it is degree 4, it will have 5 coefficients. So let's move. So f is equal to poly. We are going to use a function poly2sym. So I have a polynomial in symbolic form. So polysym of 1, we are going to create a vector that has the coefficients of the polynomial of degree 2. Now we have maybe we can say 3, then 5, then maybe 6. Then we close and with our bracket. So when we enter, we see f is equal to 3x squared plus 5x plus 6. The coefficients are 3, 5, 6 as we enter them. What if now we want a polynomial of degree maybe 3? Let us say f1 is equal to poly2sym. Then we create square brackets. Now we put in 3. Okay, let's begin with 5. Then maybe 6, maybe 7, maybe 1. Close our square brackets and our parentheses. So let us enter. We see we have a polynomial of degree 3. Now, Matlab uses x as a default variable. What if now we want to put t, so that we produce a function of t of any degree? It could be a polynomial of any degree, but in t, not in x. So what do we do if, for example, we want to produce this first one of degree 2, but in t? So what am I going to do? Let me maybe just select this. I copy and paste it here. So what I do, I put here a comma t, then I close my parentheses. Now what happens if I enter? I will produce a function f, which is a polynomial of degree 2, but in t. So we have 3t squared plus 5t plus 6. If also I want to produce another polynomial of degree 3, so I will do the same. I will just give the coefficient. I will give the vector of coefficients, then comma the symbolic variable that I want to have in my polynomial. So what if I also have maybe the coefficients are in fractions or they are rational numbers? Now what I do, I will say maybe let me first of all we'll bring this one, and what I will do, I can say this is out of 3, out of 4. Okay, then this 5 is maybe out of maybe 6. Then this 6 maybe is also, maybe let me say, out of maybe out of 5 also. Okay, let me say out of for example 7. Then in t I close. So I'll produce a polynomial of degree 2, which is 3 out of 4t squared plus 5 out of 6t plus 6 out of 7. If I want now to integrate, so I want to integrate polynomial maybe f. So what I do, I will call the integral of f as another function, maybe z, which z is equal to, now I will use function int to have a symbolic integral first of all. So I'll say int of f with respect to t. If I don't mention t still, Matlab will produce the symbolic integral of f. So what is z? You can see z is now an integral of f, which is now, how can we see it simplified or in a human readable form? I can use function pretty of z, then it will bring it clearer. You can see now it is t into 21t squared plus 35t plus 72 divided by 8. Yeah, so that is the integral of z. Now, what if I want to evaluate this integral with the limits? Now, what I will do, I will say maybe this is going to be z is equal to integral of f with respect to t from limits 0 maybe to 7. We close. So when we put in, we find that z, let us say pretty of z. So you can see that is how we can integrate that particular polynomial and produce a value that is symbolic first of all, and also when we have limits, we can always put the limits. Now you can go ahead and create any polynomial of any degree. For example, now I can say, for example, polynomial is d, which is equal to poly2sym. Then we create a square bracket and we create a polynomial of degree, for example, 5. So degree 5. So what we'll do, we have 6, 7, 8. So we said if we want a polynomial of degree 4 or 3, you give 4 coefficients. If we want a polynomial of degree 4, you give it 5 coefficients, like that, like that, like that. So we want a polynomial here of degree 5. So what we will do, it will be, now we add another one, then we close. So this is a polynomial of degree 4, and you see we have specified 5 coefficients. And if we wanted it to integrate, we can just say now int integrating d with respect to t from maybe 1 to maybe 6. Okay. Okay, we have integrated this with respect to t. Okay, what we can do is put int of d from 1 to 6. So you can see the answer is 62,305 out of 6. Thank you so much. This is how you can create a polynomial in Matlab. Then go ahead and integrate it, and then it means you can do anything with the polynomials in Matlab. I thank you.